patches which can make it look as though it is a tree, but then it is made out of concrete. But this can also be structural. You can see this is a concrete fabric formed structure in colored concrete supporting a structure. So it is not somebody's imagination. This is something which has been done. Is that the indication for me to close? I don't know. I heard a bell. You can see such beautiful structures are possible with fabric. These are slab formwork, reinforcement, concrete being poured, and beautiful slab being created out of fabric form. Wall panels, you can see how beautiful that wall looks. The one which is at the back, which looks as if it is made out of stone, is basically a form finished concrete of that which is made with different types of formworks that are there for fabric form. You can have all kinds of designs that you can think of, only a formwork will have to play around. Trusses, you can have now trusses which are the exact shape that you want. All kinds of shapes are possible with fabric forms. The form on the left side is the fabric form which is stretched in a particular fashion, concrete is poured into it. Translucent concrete, already people have started talking about it. In last webinar there was even a demo on this. There are several ways of producing this. One of the simplest ways is to mix glass fiber or acrylic rods into concrete and then try to make it translucent. You can also use optical fibers which bring light from outside to inside and give you that beautiful appearance, making the light to come into the another variety that is being talked of. This is also called something like translucent concrete, but then it is called light transmitting concrete from a company called Lucon. Unlike other versions that use acrylic rods or optical fibers, this is made out of translucent fabric stacked layer by layer into fine grained concrete. So this is a different variety of concrete that we are talking of. A beautiful, organic lines can be captured, but it is at the same time it is very sturdy and the light is virtually a lot less if you look at the structure. This is something which will come in future, a strong but very transmitting concrete landing. Now, this is something which indeed is possible, but a concrete rare projection screen. Can you use an opaque material like concrete for projection? If you can bring light carrying optical fibers, why not? On the top right hand side is the panel which is the concrete panel on the right side, and there is a transmitting panel on the left side which allows the light to create a lot of patterns. Now this is something, it is a lot of pixels which are getting lit at different points of time, conveying different things. You could probably look at this as a picture or light or information board which will start displaying things. But then this is not made out of glass, made out of concrete. So of course it is one of the heaviest projection screens that you can think of because it is concrete, but still the potentials are very, very interesting as the website says. This was developed by Christopher DuPont and Leonard Maxwell, a student of architecture, and Jonathan Beton. It is in a Danish group which has come out with this wonderful idea of using integrated lighting as an interactive media in concrete as a rare projection screen. Bendable concrete, already people have been talking about it. We are so happy about the steel behavior. You want concrete to behave like steel. You want it to bend like this without breaking. When we have seen our 3-point bending test, so we need to apply load and break 3 points. But here is something which people have tried. It's called as engineered cement composite, which can bend and it can take this kind of bending behavior without cracks. Fiber concrete is another thing that people are talking about. We have talked about smart concrete, where fibers were there. Fibers would, react with the strain and the resistivity of the fibers changing and signals to eliminate. Now, fiber concrete is something which people are talking about. This again in Japan. that they have developed this. What special they have done is that they have started fixing RFIDs, that is radio frequency identification tags, onto concrete, and this radio identification tag takes the information from the concrete, and there are certain devices. If you take it near that, the RFID interacts with that device and it starts talking. It means concrete will start talking to you. Hey, I'm not well. Something is wrong. Please do something. This is something which is likely to happen. The fiber concrete is something which will tell you if there are distresses, if there are changes that need to be done, and this is something which is a wonderful integration of the telecommunications, electronics, and civil engineering in one place. Again, everybody is talking of nano, and as our Guru Dr. C. Viswanatha would say, what is the need for looking into concrete, or what people thought? It is such a coarse material. Why magnifying glass at all? Then they realized that not only magnifying glass, even an electron microscope would be useful, because we are talking of transition zones between the cement matrix and the aggregate. Now they are trying to talk of engineering the structure at nano level to see that the creep, which is the most important factor in design of structure, because they are very much worried about creep and creep deflection. And if you can reduce the amount of creep by feeding the concrete at nano level with nano materials, you can have the cement which is more dense and have less creep, and the lowering of the rate of deformation by 2 to 3 times. And this is something which means a 100-year-old building will last 16,000 years. I mean, we are talking of huge durability possibilities if you can reduce the creep in cement and in concrete, which is possible by using nano materials. Self-cleaning cement, already you must have seen this. A lot of photocatalytic agents are, especially TiO2, is being used, and this is something which can clean not only itself, it can also clean the atmosphere to which it is connected. So a lot of airborne pollutants, including VOC, SOx, NOx, can be absorbed and can be converted to harmless materials like this. So this compound can break down into oxygen, carbon dioxide, water, and sulfate, and there will be a very little impact on this. So we are talking of cement or cement-based materials which can clean themselves. This has come in glass, now it has come in concrete as well. A few more slides. Foldable concrete. We thought concrete was dull, grey, dead. We now realize that it is no longer grey, it is no longer dull, it is not dead. We thought that it can't be moved. Now people are even looking at possibilities of moving the concrete by making foldable concrete. So this is something to do with structure, but then a possibility that can be thought of by the precast industry to make concrete curtains which can, you can cut the stadium into half by this folded concrete, have 2 events on either side, afterwards fold, and have one full stadium for a larger event. That kind of possibilities are there in concrete. Papercrete also you must have heard, where anything and everything that is brown paper is used as aggregate. This is another wonderful area in which people are working. These are likely to happen. So this is inflatable concrete homes, a concrete home that you can build from a bag. A bag weighs about 230 kg. When inflated, covers about 16 square meters. Costs about 1.1 lakh. Much lesser than even a porta cabin that you normally use for temporary structures, and very, very easy to manufacture. People are talking of concrete cloth. I in fact would like to show you a very small clip. I hope the organizers will not show me out. Audio is not coming. audio is not working. Anyway, I can explain to you. This is a concrete cloth.
Flood defences, roofing. Concrete cloth is a revolutionary building material that is changing the way that concrete is used. Concrete cloth is a flexible fabric that hardens on hydration to form a thin, durable concrete layer. It enables the rapid installation of concrete infrastructure across a broad range of applications, including ditch lining, foundation binding, erosion control, mining, pipe protection, trackway, flood defences, roofing, emergency helipads, and many more. The cloth consists of a three-dimensional fibre matrix containing specially formulated dry cement. A PVC backing on one surface ensures the material is completely waterproof. Hydrophilic fibres on the opposite surface aid hydration. Concrete cloth is extremely easy to use. There is no mixing, measuring or compacting required. Just add water. The cloth cannot be overhydrated. Construction work can continue in the rain and in extreme temperatures. It will set underwater and even in seawater. Concrete cloth is supplied in a range of thicknesses and in bulk rolls, or man-portable rolls where plant equipment is not available. It is easy to work with and can be nailed, stapled or cut with basic hand tools. Once hydrated, concrete cloth remains workable for 2 hours and hardens to 80% strength in 24 hours. Concrete cloth is a ceramic and will not burn. It has been independently certified to Euroclass B. Concrete cloth has excellent chemical, weathering and wear resistance, double that of most conventional concretes, and it will not degrade in UV. Concrete cloth replaces poured or sprayed concrete for many applications, reducing the cost, time and environmental impact of construction work. For further information, visit concretecanvas.co.uk.
That's what I did, so I want you also to visit this. So, it's possible now to have concrete in the form of cloth. It's available in the bag. You can have this kind of wonderful sensors and so on, unconventional. So, friends, relax. Concrete is there to help you. You can make anything that you want out of it, not dull, dead and useless material, but it is a very, very potential and beautiful material. You have seen what can happen. People are even talking of, concrete in the moon, on the moon. So when we go and try to start, not me, you youngsters, when you go and stay in on moon, probably you will have concrete houses there as well. So this is something which is possible. Both of them are made out of concrete, and you are accustomed to this. You may have to get accustomed to this as well. So thank you very much for giving me this opportunity.
Thank you, Dr. Kalgal, for a beautiful lecture. Dr. Kalgal has given us an overview of the enormous possibilities of concrete. I see that we have a full house crowd with only standing room available. What I will do is, taking the privilege, anchor privilege, I would like to request all of you whether we can skip the question and answer session because already more than 1 hour late. But what I would like to request Dr. Kalgal is, Dr. Kalgal, if you can please tell your email ID. I think many of them have questions, not one but many, and I think they can write you directly. They can make a note, please.
Yeah, the simplest, of course, my official ID is too long. Simplest ID is mkalgal@gmail.com. MKALGAL@gmail.com.
mkalgal@gmail.com. I see a number of people scribbling away to glory. You'll have a lot of questions. Your mailbox will be full. Dr. Kalgan. And audience, thank you very much. You're really making my job very helpful. I would like to tell you that when I announced that 11:45 we start the session, Dr. Kalgan was the one who walked in first. I really appreciate him for that. So we wish that every speaker is on time. Now, our next speaker is going to be Nagesh Puttaswamy, but before that, I would like to request Mr. M.N. Ramesh to please give a memento to Dr. Kalgan as a token of our appreciation, please. And Dr. Kalgan, thank you so much for understanding. Not taking questions.